Hey, good morning, good afternoon, and maybe even good night for some of you. My name is Amit Saha. I'm a principal engineer at Cisco Systems, Bangalore. So on behalf of the rest of the iMobile team, Prashant, Sandeep, Vinayak, Karthik, and Rohit, I'd like to welcome everyone to this webinar. So let me give you a brief overview of what the iMobile ACM chapter is all about. The iMobile ACM chapter is the India chapter of ACM SIGMobile and was formed in March of 2019. So it's a very new chapter. It was formed as a community of researchers and practitioners in India with an aim to develop a greater passion for systems research in the country while adhering to the global charter of SIGMobile. So in general, the chapter wants to facilitate research in the theory and practice of all areas related to the mobility of systems, users, data, and computing. Maybe work on the evolution of portable computers and wireless networks, convergence of mobility, computing, and information organization, and improve access, services, management, and application for mobile computing and communications. So if you have heard of conferences such as Mobicom, Mobisys, MobiHawk, Census, those are basically the conferences which focuses on the same areas that iMobile ACM chapter wants to facilitate and develop within India and the nearby regions. So in addition to these webinars, we have also been having workshops. So we have had the first ACM workshop on autonomous and intelligent mobile systems called AIMS in 2020. And we'll be having the second edition in 2021. So please do visit our website if you're interested in submitting papers. We hope to get lots of good, exciting papers. There's a lot of good research going on within the country. The conference is international, so anybody can submit from anywhere. So we hope to get good submissions this year as well. Right. In addition to the webinars, we have, in addition to the workshops, we have been arranging webinars such as these, and Karthik has been our main person arranging these wonderful webinars. So without further ado, I will hand it over to Karthik, who will explain more about the webinar and introduce our speaker for today. Karthik, over to you.
Okay. Audio good, Amit?
Yes.
So with great pleasure to introduce a good friend and colleague, Tadashi, to speak for our iMobile ACM webinar series. So Tadashi is going to be talking today about well-being, and pretty hot topic today, particularly given the situation that's happening. In fact, I was reading that Amazon has introduced their own fitness tracker yesterday. So Tadashi is an active member of the SIGMobile community, and also runs his own workshop called Wellcom, which is part of the Ubicom conference. Tadashi has done his master's from Carnegie Mellon and his PhD from Cambridge University. Before I hand it over to Tadashi, there are a couple of ground rules we go through the webinar. So let me just quickly take you to that slide. Okay.
Karthik, if you can speak a bit louder.
Okay. Better now? So just a couple of ground rules before I hand it over to Tadashi. So everyone, please stay on mute and have your video turned off. I still do see some people's audio turned on. Please make sure it's muted, and also video, since we are recording. So if your audio is turned on and your video is turned on when Tadashi is talking, then suddenly the video will move to your screen, right? So please stay on mute and video turned off. During the session, please use the chat to ask questions. So open your chat window, make sure it is pointed to everyone, and you can start typing your questions here. Right? So Tadashi will also be looking at that chat window to kind of understand what are the questions that are being asked. And it also, most importantly, help in reducing the duplicate questions. I'm sure a lot of people will have similar questions, right? So in what we plan to do this time is kind of introduce Q&A breaks. This is a bit of learning experience from the last webinar. So we'll give a logical break. Tadashi will stop at some point and then probably answer some of the questions. And we will continue after that, right? Then at the end of the session, we can, if we have time, we'll go back to the classical way of opening audio questions, which will be fun, if we have time, that is. And if you don't like this protocol and have any suggestions, do mention it at our feedback, which we will be sharing post this session. Okay. I'm sorry, Amit is telling me that my voice is very feeble, but I hope everyone kind of got the grasp of what I was trying to say. Okay, so Tadashi, I'm going to stop sharing my screen and you can project yours.
Thank you, Karthik. So can you hear me right now?
Yeah, you're audible.
Okay, then what are you looking? Is this the right slide to be shown?
Yes, can see the starting slide.
Okay, so good morning, good afternoon, good evening, everyone. I'm Tadashi Okoshi from Keio University, Japan. So in the beginning of my talk, let me introduce something about our university, Japan, our university, and our research group. Then I think I'm going to have 2 sessions. So I'm planning to have each session 30 minutes each, after which I'm gonna take some short break for Q&A. So let me introduce myself briefly. So I'm Tadashi Okoshi. I'm actually, I have been researching on mobile systems, ubiquitous systems, including recently activity recognition, mobile sensing, and the mobile machine learning, and human attention management particularly. And for the recent years, I'm broadening our research area to what we call computing for well-being. And my career is kind of interesting. And I went to the United States and I got a master's degree from Carnegie Mellon. And after that, I actually worked for 7 years in industries in web area, web and social networking area as a product manager. Then after that, I came back to academia to get PhD with help from, people like Karthik, people from Singapore Management University, my old friend Rajesh Balan, who gave a talk for the last seminar for this. And thank for anyone, many people. I'm happy to doing this research right now. And this is this may be interesting or unfamiliar for you because this is the world map centering Japan, and this is the world map we are using in Japan. And people is selfish in anywhere in the world, and people tend to be locate themselves in the center. And so this is here in the Tokyo, and our university Keio is basically located in this Tokyo area, and we have actually multiple campuses in the greater Tokyo area. So this actually red circle indicates 50-kilometer circle from the center of Tokyo, and yellow dots are actually each campuses in our university. And our university, Keio, K-E-I-O, is actually the oldest private institute, oldest higher private educational institute, founded in 1859 by a founder, old scholar, Yukichi Fukuzawa, the guy in the central picture. And if you visit Japan, this is the 10,000 Japanese yen note, and the face printed on this note is Mr. Yukichi Fukuzawa, our founder. So if you have any chance to come to Japan, let me know, and you are always welcome. And a little bit about more Keio. So Keio is not only the university, we have actually elementary school, 2 elementary schools, 2 junior high school, 5 high school, and department, graduate school, and even for even university hospital. So it's a kind of a huge educational institute and research institute. And these are, yeah, the glance, the overview of our campuses in the different areas. And our area, our campus is the greenest one. And in other words, the most that are far away from the central Tokyo area. And in this campus, we are, formulating a kind of a research group called the Welcome Research Group. So a research group for researching computing for well-being. And actually, when we talk about well-being, there can be many different research topics. So for example, according to the definition of well-being by WHO, so people's well-being, in other words, it's a kind of a good condition in our physical, mental, and social conditions. And so, of course, in the recent years, we have computing technology. So I would say we have, well, not only 3, we have 6 different areas like physical condition in the physical space and the cyberspace, and mental conditions in physical and cyberspaces, and so forth. So, well, we name each of the area. For example, I am particularly focusing on the mental well-being in cyberspace, for example. So this is one of the topic I'm going to present for this talk, but many other members, students, actually from freshman to PhD students, we have more than 40 or 50 students as whole, and many students are individually researching in different areas. Then, in other perspective, or in another framework of our research is like this. So our group is mainly focusing on the right-hand side, smart life. Well, focusing on people's life from the birth to the death, actually, or even after death. From childhood in our, middle age, or even in the aged, old timings. So possibly we have multiple different research themes, which individually involves sensing technology or big data analysis and eventual information feedback or actuation of machines or robots or whatever. And on the right-hand side, we have a series of a kind of circulation from sensing, analysis, and actuation information. But on the other hand, we have another group focusing on smart cities or smart communities, which also involves sensing, big data analysis, and the information. So this kind of circulation is, that's a kind of common computing architecture or framework. Then today, for this talk, I'm going to focus on particularly for the right-hand side, okay? So, let's zoom the previous slide, this one, right-hand side, a little bit more. So from sensing, data analysis, information sharing, and the final information feedback or actuation, we have multiple different technologies going on. The first one is, of course, sensing. So we have a kind of active collaboration with the University of Oulu in Finland. And the guy on the left-hand side is Professor Denzel Ferreira. And the right-hand side is Dr. Yuki Nishiyama. And oh, actually, he just come back to University of Tokyo. But this aware framework, you can access this website, a kind of a universal mobile sensing platform, which works both on iOS and Google Android platforms, and with which you can enable or disable any kinds of embedded sensors in smartphone and smartwatch platforms. So for those are interested in this kind of mobile sensing, this aware framework is the one of the very useful framework for your research. So yeah, let me advertise this. And this Dr. Yuki Nishiyama, he's a kind of a guru of iOS mobile sensing. So he just published a nice, interesting paper about iOS mobile sensing. So yeah, please Google him. And so, well, we are basically focusing on mobile sensing and wearable sensing. Of course, we occasionally use, for example, brainwave sensors or BCIs, but in case of real-world deployability, the brainwave technology is not really common, right? And on the other hand, everybody, all of you will has own smartphones or smartwatches. So by utilizing this smartphone platform is a kind of well, it's a really good way to do research. Then another focus of ours is big data analysis of personal data, personal sensor data, in terms of different internal aspects of ours, like emotion or mood or any other, for example, productivity of the day. From the sensor data, we built that kind of machine learning model. And for example, yeah, I mean, from mobile sensing data, the types of data you can collect is a kind of limited because, you axle metadata, gyroscope data, location. Yeah, it's a kind of well-known set, but you cannot detect physiological data like brainwave or something like that directly. But indirectly, you can estimate people's emotion status or mood or productivity of the day, that kind of factors. This kind of big data analysis can reveal for you. And after that, sensing, analysis, and the next one is sharing. So I think many of the personal data research is focusing on users individually. So if the system senses your sensor data, the systems analyze your status and gives that result back to you. But why don't we share those big data analysis data or any kind of personal data? So one of that kind of research is called Smile Wave, and that is a kind of a smiley Instagram-like social network application. And yeah, it may sound interestingly or not, but there is a kind of a famous phenomena, well-known phenomena, like emotional contagion printed on the top of this slide. Emotional contagion is actually people's emotion is contagious, so spread people by people, and especially through people's facial expression. So suppose you have a friend who is smiling always, right? So suppose you have a friend he or she is smiling always, always. Then, every time you look at that friend, he or she is smiling to you. Then what do you feel? You gradually feel to somewhat funny, interesting, or happy, but that kind of positive way. And that is actually an emotional contagion. And there is a kind of a series of research about psychology around that topic. And when a human sees other people's smiling facial expression, before you feel happiness, your muscle here, your facial muscle actually changes or works to change your facial expression smiling. Interestingly, right? That is before you feel happiness. That means you don't smile because you feel happiness. You smile because you see his or her facial expression. Then after you make a smiley facial expression, you will feel happiness. It's quite interesting, right? But that kind of phenomena called emotional contagion does it really happen even for on small social media or online situation? So this research investigated that, and we actually confirmed that kind of a facial expression based emotional contagion actually occurs in the social media. So this is a kind of example of sharing information or even for emotional information between people. Then, so this it was the sharing, sensing, analysis, sharing. And the final one is information feedback or information provision back to people. Suppose or imagine your smartphone or a smartwatch or a personal computer. You have a big number of applications or services. Do you remember how many web services you have registered, right? You, for example, register to Amazon or shopping services, health monitoring services, or you must have registered to many web services or applications. Eventually, all of that application will send you some information, right? And you or me or human is the entity who is receiving that information, right? So eventually all the information is basically coming back to you. So how is the system able to provide the information efficiently? One example of this kind of research is like this. This research is actually done by Yuki Nishiyama, who is developing Aware framework right now. He was actually originally a university baseball team player. He's a nice baseball player. And this research investigate the efficient way of information provision for the baseball team to promote exercise. So for this kind of team, they want to have more exercise, and they're better to have more exercise. But how we can share other members are training this much or that much, and is the competitive way or collaborative way of information provision, like, hey, you do more exercise because this player is exercising more. This kind of it's a kind of a strategy that triggers competition, right? But in other way, for example, okay, you guys, 10 people, let's make a team and let's achieve, for example, 1,000 times sit up exercise for a day. That's a kind of a collaboration. So competitive way, collaborative way, what kind of information provision is really useful for this kind of team towards their behavior change. So this kind of information provisioning is the fourth element of the research and the most interesting part personally for me. And looking back my old days in Carnegie Mellon, actually Carnegie Mellon University is in Pittsburgh in Pennsylvania in United States. And this is Carnegie Mellon University. 20 years ago, I went to Carnegie Mellon and I studied as a graduate student. And 20 years ago, it was 20 years ago. And I joined a project called Aura. Aura is a kind of NSF funded project for ubiquitous computing. And here, there's one important description about right here. This is the guy called Harvard A. Simon, Professor Harvard A. Simon, actually, who is the Nobel Economics Prize awardee. And he's also a computer scientist, and he is actually one of the founder of computer science in Carnegie Mellon. And in 1970s, 50 years ago from now, he already found that the most important resource in computing is humans' attention. Suppose your smartphones or computers or networks. Day by day, we have more powerful processor, a bigger amount of memory, or faster wireless network, or 5G, or even faster network. But on the other hand, our humans' attention is not really changing. Our physiological, our body is not really changing that kind of fast speed. So the motivation here is our human attention is a kind of a bottleneck in computing. So after I went to Carnegie Mellon, I said I spent 7 years in industries. There was a blogging industry. And 20 years ago, around year 2000, there was actually era, even before Facebook or social network, right? The Facebook actually established in 2006. So year 2000 is before Facebook era or Twitter. So in that kind of age and timing, there was a huge boom blogging. So many people, many users wanted to start their own blog website. And yes, I just launched my website, blogging website. And the first entry of my blog. So, okay, let me introduce myself. I'm Tadashi Okoshi, hello world, something like that. But okay, I wrote my first blog entry, but well, you can imagine nobody sees your blog, right? Because you're not, well, I was not famous. You may be famous already, but you just finished your first blogging entry, but nobody knows the existing of that blogging website. So I was working a blogging company in San Francisco, West Coast, and Tokyo for 7 years. But we had many customers, many bloggers, right? But a huge problem in the blogging industry is so much information, but our attention or our time is limited. So we cannot read all the blogs, right? We cannot consume all the information. So that kind of imbalance between humans' ability and amount of information or explosion of information has been my own research motivation. So after I worked for this industry for 7 years, I came back to academia. And this is the graph for, well, this is by projection by a company called Gartner, a well-known marketing research company, about projection of IoT devices. So, well, this graph shows to the end of year 2018, but you can see, and as you know, in the era of IoT, the number of connected devices has been exploding, right? So not only our smartphones or notebook computers, but also sensors, actuators, or home appliances, many kind of IoT devices has been connected, right? Then in that kind of IoT era, as you know, on your smartphone, according to this survey, the average user has about 100 applications on the phone. And yeah, sorry, continuously he or she is installing the applications. And lots of more devices like Fitbit band or wearable glasses, right? Then you have much push notification from many websites and applications through your devices to your attention. So yeah, open your smartphone and then open your notification list, right? Yeah, of course, I have lots of notifications that I cannot see, and I end up ignoring recently. But that push notification, the situation around this push notification has been getting more and more severe in the recent days. So this, after I came back to academia, this is a particular good research topic for me. So yeah, to summarize the situation, yeah, let me plot the situation in a 3-dimensional axis. The first one is we have an increasing number of devices. And we have a large number of applications. And of course, we have all day long computing experience, right? So 24 hours a day, we are using computers. Then, okay, how can we handle that kind of situation? So as I told you, our human attention has been a bottleneck. And I actually study a little bit, not a little bit, but about the cognitive psychology. So humans' attention has been conceptualized or studied as a kind of the same thing with the operating systems in computer science, actually. So when you look at the figure on the left hand, this bottom side, this is a kind of a schema figure about cognitive psychologists, about humans' attention. So you can see available capacity or allocation policy. Those are kind of a well-known words around computer science operating system area, right? So psychologists have been already studied about humans' attention and found that our amount of human attention is limited just like memory in computer. And that limited amount of attentional resource will be allocated into different tasks, just like operating system allocates CPU time to different applications. So suppose you have a laptop computer and you are using a Microsoft Word to writing some document, and suddenly you have notifications, three notifications like this. And in that situation, your human attentional resource will be splitted and allocated to Microsoft Word editing and other topics at the same time, simultaneously. And this kind of situation is called divided attention. And it was already studied that when the people's attention is divided, our performance in terms of productivity or emotional status or social attribute, that kind of status is going to be bad. So, well, I found that, well, those kind of people already studied human attention resource, and it's just like computer science operating system. Wow. So it's a kind of coincidence, but it's quite interesting, isn't it? Right? So I found the computer system, including operating system, application, network, or information system, needs to be aware of our human attention so that computer system can provide us any information in a way that our human attention is not in a bad situation. So as a concrete solution, since year 2014, I constructed a kind of middleware on smartphones which detect users' interruptible, or in other words, opportune timings for push notification. So suppose you have your bunch of notifications on your smartphone, but basically right now, the notifications are coming in random timings from your viewpoint, right? So even during my talk, some notification may be coming, right? But if this system can detect that for me, it's not a good timing to push notification right now, right? It's in the middle of my talk. So if the system can find nice timing for push notification delivery, that's going to be good, right? Because, for example, after this talk finishes, I'm gonna feel safe. I'm gonna feel kind of a relief. I'm gonna feel, okay, I can take a break. Then at that time, the system can deliver push notification. If so, I can access the information, right? So finding such kind of good timing is a nice topic, I suppose. So I designed a kind of middleware called Atelier, and say, yeah, this slide is fine. So suppose your situation with smartphones. You sometimes use smartphones actively, like left-hand side, or in some other times, you just carry your smartphones, right? But what the system is looking at is a concept called breakpoint, which is a kind of a boundary between people's activity, right? So breakpoint is a kind of boundary. And while you are actively using your smartphone, you may write email or text some chat, right? But just after you send out your email, by pushing send button. It may be a good point, good timing for you to get push notification. Or suppose you're walking on the street by putting your smartphone on your pocket, right? At the traffic signal, you may stop walking, right? To wait the traffic signal changes. That timing is actually change your walking activity to standing activity. So if the system can detect that kind of activity change, and that is actually, that kind of timing or changing timing is called breakpoint. And according to psychology, delivering information in that kind of timing was actually already observed nice human status, like lower cognitive load or lower stress. So I invented kind of a mobile sensing technology. For example, well, actually, going back to academia in year 2013, but just before that, I actually spent 6 months in Singapore Management University with Professor Rajesh Balan, and I learned the basic of mobile machine learning and mobile sensing. So the technology is basically using accelerometer or some other sensor data from the smartphone and create a machine learning model that classifies for the last some seconds, time by time, this timing or this sensor data is a nice timing to interrupt or not. So of course, we had to collect sensor data, and we needed to have ground truth annotation. So we actually had an experiment with people having asking the annotation of ground truth, and we actually even built a system either on Android mobile phone and Android smartphone. So with this system, we had a kind of a human-computer interaction style experiment. So we hired 30 people for group A and another 30 people for group B. So we asked for them to install our application to their own each smartphone. And this is a secret, but for group A, 30 people, our system actually worked, and push notification was delivered or presented in a machine learning based nice timing. But on the other hand, for other 30 people, group B, it was a secret, but our system did not work. I mean, that was intentionally. We did nothing. We did nothing actually. So for the duration of the experiment, like 1 month, 30 people group A experienced our nice timing notification. On the other hand, other 30 people experienced the ordinal notification. So after 1 month, this is a user study, the picture of a user study with a bunch of students. So our 1 month user study, we found that our machine learning based timing finding actually works. And this guy, group A, experienced significantly lower mental effort and the cognitive load. So that was quite interesting. And so we designed a middleware in a system research way, and we conducted a human-computer interaction style experience. Then we published papers for PowerCom 2015 and the UbiCom 2015. And by doing experiments on smartphones or combination of smartphones and smartwatches. So, and very interestingly, we had a nice improvement of system performance. So with our system, people felt less stress, less mental effort, less cognitive load, and good performance for push notification. So this actually, my talk has been quite long, but this is the first part of my talk. And well, going back to the beginning of my talk, I went to US. I went to industries for 7 years. I came back to academia after that. Then, but eventual research problem I found was actually already had found by Professor Simon in 1970s, right? But the situation was getting severe. So the lessons learned from this experience is like this: find and solve a problem in the future. So, well, I think many of you are seeking your own research problem. So we are in this figure, we are right now here. This is a time axis. If you focus on the current problem, right? That problem maybe should be well-defined or well-known problem, right? So in year 2020, there are many problems in the society. But at the same time, for this problem, many other people are actually already tackling. So there are many competitors, and it's quite hard to make a big difference, right? Instead, please try to find a problem in the future, 5 years ago or 10 years ago, based on the technology advancement or social situation and the problem changes. So imagine some problem in the future, in year 2030. What type of problem are we supposed to have? And solve that problem ahead of anybody. So this is a kind of lessons learned for the first part. And yeah, I would like to access some of the questions right now. And yeah, let me open some chat window. Okay. So, wow, okay. What is the questions? Question: how was the mental effort, cognitive load measured? Oh, okay. Oh, it's continuous. Okay. So the first question is, how was the mental effort and the cognitive load measured? So one way is a well-known methodology called NASA TLX. You can Google that. But NASA TLX are kind of a questionnaire originally created for NASA's astronaut or Air Force pilot, because astronauts in a spaceship or sorry, astronaut, okay, in a spaceship or Air Force fighter, right? Airplane. There are so many, measurements or controllers. You need to look at many parameters in a cockpit, right? So NASA originally needed to design the best user interface in a spaceship or the aircraft. And during that research, they invented a questionnaire called NASA TLX, which can measure the actual workload. So there can be there are actually 6 different axes in a TLX questionnaire, but you can use that to measure quite different types of workload for your mental. Okay, then the second question is continuous intervention more reinforcing than a trigger based one? when dealing with emotional support. So, okay. Continuous intervention. Right. So that actually, that is actually related to the second part of my talk. So yeah, let me go on to the second part because, yeah, I can answer your question. So in 2015, we had two papers published, fortunately, in pervasive computing, ubiquitous computing conferences. But after that, we wanted to investigate
I
how
had
this
kept
kind of
chat
system.
window also open so that you should able to.
Sorry. Sorry, I couldn't hear you very much like that.
Carry on. Carry on. I
Okay.
think that was somebody just speaking. Yeah.
Okay. So, okay. Then after that, we wanted to investigate how these systems, how system works in the real world situation. So fortunately, at the conference of this Ubicom conference, I had a fortunate human network with a researcher in industries, which is Yahoo Japan Corporation. And so, well, you may or may not know Yahoo. Yahoo in the States, in United States, is already, I think, gone. The brand of Yahoo is gone because their business didn't go well. But particularly inside the Japanese market, Yahoo Japan is a kind of a quite independent business system, and they are still doing very well. And for example, search engine market, they have, Yahoo Japan still has a significant amount of search engine market share, as well as Google. So Yahoo Japan is a quite big business in Japan. So we fortunately had collaboration with Yahoo Japan, and we successfully embedded this technology inside their Yahoo Japan smartphone application. So you can imagine, well, I don't know very much about the business in India, but in case of US, for example, so, okay, Google has its own Google app, right? Or Facebook has its own app, Facebook app. Just like that, Yahoo Japan has its own Yahoo app. And the number of install base is more than 10 million. So, well, roughly speaking, more than 10%, but I don't know, 20 or 30% of the Japanese population are using this application. So it's a kind of huge application. And we successfully integrated our logic into this application and tested, evaluate how this adaptive notification works in the real situation. I mean, with the real user, real notification content, and in a real world smartphone usage. So fortunately, for example, yeah, let me go to the, so we had a kind of a huge HCI style experiment here. The number of experiments were more than 600,000 people, not just 50 or 30 people we usually have. So we were quite fortunate situation. And so we collected a bunch of data from user. And according to that, when we send a notification in a machine learning found good timing, their response time to notification reduced by almost 50%. So the user really quickly respond to a notification. And also their click rate, from the view of the business, how many percent of notification will be clicked by the user? That really matters for the business, right? Because when the user clicks the notification, this user eventually goes to the business website, may purchase something like that, right? So the click rate of notification is a kind of a big KPI for the businesses. So fortunately, that click rate actually significantly and increasingly, constantly increased to the notification, the duration of the experiment. And also, you can imagine that Yahoo has many different services like a Yahoo Shopping, auction, Yahoo, how can I say, movie, Yahoo, Yahoo, whatever, more than 30 services. So what Yahoo is defining engagement is a kind of a degree of the customer in terms of customer loyalty, how well the user is behave for their business. So that kind of calculation is quite confidential to inside Yahoo Japan. So I don't know the formulation, but that kind of engagement value also increased consistently during the experiment. So, well, we have lots of different results more than this, but the point is that very fortunately, we could integrate our research software, machine learning and mobile sensing software into the commercial application and succeeded to have an evaluation. So this evaluation started from 2016 to last year, 2019, continuously, and answering the previous situation, question. We had a kind of a reinforced learning methodology for that kind of experiment. Not for 4 years, but I think that the longest duration was several months, up to 1 year. The system had been deployed for each user continuously. And day by day, the user's sensor data and the log had been uploaded to the server. And every night, Yahoo's server cluster created a new model. And the new model will be sent back to the user's smartphone. So this kind of circulation is, in some sense, we can treat it as a kind of a reinforced learning in machine learning. And that kind of circulation throughout the duration of the experiment surely increase the effectiveness of our system. So we had a last presentation in ACM's KDD 19 last year. And this, for example, graph showed continuous reinforced learning after approximately one year. So the gain or the effectiveness of our system actually got 10 times more. Then sensor input or information channels. Okay. Sure. Which sensor input? Okay, so yeah, some people are interested in what kind of sensor we used. So in case of Yahoo Japan collaboration, we almost use solely on activity recognition, Google provided by Google's API. Because in the real world situation, do you remember this figure, right? So on the left-hand side, our system wanted to collect people's interaction with the application or Android OS. But that involves concretely the accessibility services, which actually, how can I say, which looks at users typing or tapping, that kind of interaction deeply. So in the real world, this kind of sensor is a really privacy sensitive. So in the reality, we could not use the left-hand side sensor data. So we solely focused on activity recognition data, which returns the smartphone users' current activity, like walking, standing, sitting, or something like that. And yeah, in addition, we use some more sensor data like current volume setting, or current sleep setting, sleep or awake setting. Yeah, that kind of sensor data were used. So please refer our KDD 19 paper for that, for detail. But basically, we are using that kind of sensor data. So, well, so fortunately, we had a 4-year experiment, and finally, yeah, the effectiveness of system got 10 times more, 2 times more. Yeah. So let's say, yeah, the click rate, gain in click rate got better 10 times more. And we especially used personalized notification content. So I would say each of you have on the dedicated notification content. For example, I'm going to send you football game result because you like football, right? And that kind of personalization content had more gain with our system. And also in some cases, we have really urgent notification. Like suppose we are in Japan, so we sometimes have an earthquake. In case of earthquake, we have really urgent push notification on everybody's smartphone. Like earthquake will be coming in 10 seconds. You said 10 seconds. So within 10 seconds, you need to hide under the desk. So in case of that kind of really emergency push notification, what is our system works with that kind of notification? So of course, for such kind of emergency notification, this system does not handle. Anyway, I mean, emergency is an emergency. So there's no way to delay or adjust the timing of a notification, okay? But in case we have other that kind of emergency notification, what is our system with the normal notification, how efficiently this kind of system works. So interestingly, we found that if we have emergency push notification, somehow our system works even better. So yeah, digging the cause of this is actually our future work, but this is a kind of an interesting phenomena we observed. So since I started this research since 2013, very fortunately, I had a collaboration with Yahoo Japan people, and very fortunately, I had this kind of a successful research output. And so based on that, fortunately, these kind of articles are written in Japanese, but this put notification technology was deployed as a permanent commercial component that means the research is almost over. So from the research to commercialization or the real world deployment, that kind of translation had been achieved, fortunately. So, well, the research is over, but as a research, I'm really happy to have contributed their business or more even bigger number of people's experience with notification. So, well, we talked a long journey of this research, but we, in some sense, we even broadened this research. We wanted to map people's status on the map. So because in the geographical map, for example, where is the specific location in which people is really nice to get notification? Or in other words, we can map any kind of emotional or affective internal status onto a map, right? If we can do so, we can observe how well this city is going on, right? In city of Tokyo, in city of Yokohama, what kind of feeling the people is having right now in this place or that place or that place. So this is a kind of a different axis of the research, but remember, we plot smart life and smart city on the right-hand side and the left-hand side, right? So merging together, we can combine together, plotting people's emotional status onto our city area map, right? So even that kind of collaboration is possible. So our research community have been grown. We launched a workshop called Ubi-Tension about smart notification and attention management in conjunction with UbiComp conference. And yeah, of course, this year, 2 weeks later, we will have Ubi-Tension 2020 in conjunction with UbiComp. So please visit these websites. And there are more than 40 or 50 published papers so far. So there are so many great works already published. So yeah, my talk is about to end. And the final message or final lessons I learned from my experience is you may or may not this video. You can Google this video. Steve Jobs, 2005, Stanford University's commencement address, titled "Connecting the Dots." So, well, I think many of you are quite in the early stage of your research career, and you are still undergrads or graduate students, but you don't know how your versatile experiences in your life will be meaningful in the future, right? When you get 30 years old, 40 years old, 50 years old, you don't know right now how your experience is going to be meaningful. So when you look at this video of Steve Jobs, his versatile experience was really meaningful when he invented Macintosh, iMac, or iPhone, or iPad. So in my case, my experiences both in academia, industry, both in United States, Singapore, and Japan, that helped me a lot. Right now, when I look back the past, okay? So from your viewpoint, you don't know right now how your experience is going to be meaningful. So the solution is be active for everything, and experience as much as you want, as much as you can. And you will have much versatile experience, both in academia, industries, in many countries. Then after that, it's going to be a day. You can suddenly realize, wow, my experience helped me a lot. Okay, so yeah, plotting my experience in the past. I went to Carnegie Mellon, I went to KO, I went to Singapore, I went to industries. And I was doing a product manager. So other than researcher, then even that kind of experience helped me a lot. Okay, this is it. Thank you very much.
Okay, yeah, sorry to interrupt. Guys, if you have any questions, please post. Tadashi, I see a couple of questions.
Yeah, I can see. How do you ensure that instability research does not contribute towards a mass surveillance and surveillance state? Right. So the question was, this kind of interruptibility research does not contribute towards a mass surveillance. So, well, yeah, that's a new challenge, I think. Currently, both on iOS or Android platform, those platforms are quite vertically integrated. So Google or Apple is managing or can have a control from hardware, operating system, middleware, and application. But as a researcher, I would say some kind of user-side platform will be really needed, right? Even outside Google or Apple's platform, right? So right now, as long as you have your smartphone, everything is controlled by Google or Apple. This is not the ideal situation in terms of a privacy protection. Okay, thank you. What do you wanted to say, Kartik?
No. So I just want to point out, anyone has any quick questions before we wind up, please post. Or since there's a bit of time, if you want, you can unmute yourself and talk. It'd be nice to hear.
Yes, I had another question about possible remote internship right now. Wow, that's a good question for me, and thanks for the offering. And well, remote internship, yeah, because internship involves in some kind of the real discussion between university. As a researcher, solo researcher, I'm always welcome for your participation. And in a kind of a formal discussion between universities, I think our KO University is quite open for having you as a remote internship or remote, not remote, but international graduate student. So yeah, talk to me or contact me. We can discuss.
Okay, if there's no more questions from anyone, I'd like to thank Tadashi for being part of the iMobile webinar series.
Yeah, thank you very much. And my talk has been a little bit long, but I'm really happy to have a talk with all of you.
Very pertinent that, 30 years ago when they talked about attention being the most important aspect, it still holds. And yeah, I mean, I think I reached a stage where, I just turn off everything. That's the easiest way to do it. So thanks everyone for participating. We will be, as I mentioned, this session is recorded, and for people who want to go through it, we'll be posting it on our YouTube channel. And Tadashi has mentioned his email and his webpage as well. So
right, yeah, right.
So if you have any other questions,
here,
internships, or other things relating to well-being, just get in touch. Okay, thank you, everyone.
Thank you very much. Good to see you.
Bye, Tadashi.
Bye.